Hello student, good morning and welcome back. So today we are going to learn about Form 3 Science Chapter 6 about electricity and magnetism. So electric, we already know the electric got two calculations, correct or not? Electric is what you need to calculate by using current, the ampere plus the voltage. Electric is equivalent to current and times voltage. But in current also there are two. Do you still remember the topic electric in Form 2? Do electric flow through conductor one direction or constantly changing direction? So electric current is divided to two types. One is the direct current and alternating current. DC or AC. Okay, DC means it's a direct current that flow in one direction. It's quite easy because it just flow in one direction. Like the electric that we are using now at home is a direct current. Because if we put in the plug, 3-pin plug, we know that this one is the direct current. Or we can use it to alternating current. This is the word from alternate already. Where the electric flow constantly changing direction. For example, brake, toaster, hair dryer, and air conditioner. So how to know that direct current? Usually when we buy things like we need to see lah the plug. Okay, got it will put there DC or AC. That's why when I try to fix things, I will look at the volt, ampere, and I want to check it is DC or AC. Usually by adapter. You know adapter? Oh, I got adapter here. This is my laptop adapter. Let's see. This one AC or DC? This one is AC DC adapter. What Why got AC DC one? Let's find the output The output is so many words I don't know where does it write. So many words. Output is 19 watt 4.74 ampere. AC DC adapter. I don't know. Maybe you can use both, is it? So you need to use this. This is my laptop charger You want to use this charger to convert the current either to AC to DC or DC to AC. Or when you go to buy phone charger, usually the phone charger got one thing big one, or to charge battery one thing big one. So the big thing sometimes is the converter. You want to convert the direct current to alternating current, or to convert the alternating current to the direct current. Okay, so of course we can see if from here maybe inside got to convert the direct current into the alternating current. So both can use, up to you. Okay, for example we can see example of device is torchlight, calculator, toy car. Example of generator, electric that produced by the current. Solar panel, accumulator, battery are producing the electric. Compared to the experiment that we do here, this one, if you don't use this, you know, like it depends on how you arrange this one. It can become the alternating current. How you want to arrange this thing. So you can change it. So okay, alternating current, the flow in the constantly reverse, go back. Okay, alternating current. Okay, so you need to know this thing first. Our house one is using direct current Cathode ray oscillator. Okay, so what is this? Cathode ray oscillator is an electron device that shows differentiation in the graph. Direction of current and voltage change for the direction of alternating current, direct and alternating. So this thing is to see electric. Because we are just human, we cannot see electric, but if we are Superman, maybe we can see electric. So because we are not Superman, we want to see electric, we use this CRO, which is called cathode ray oscilloscope, so that we can see the electric. So now this one in your school got already. I don't know that you got to have this experiment. My school don't have for last time. Okay, so you can control the knob to control the electric, and you can see how, if you want to see the electric, and this one we can see the electric. Okay, so here didn't show any notes, or only straight away ask you to do example, so you can show all these things. Okay, so this thing is actually for you to see the electric. So by using this, you can see whether it is AC, DC, you can see the volt, you can see the frequency, you can see the amplitude, and so on. The electric stable or not. Okay, you can see. So basically here is they want to adjust the X shift and the Y shift. So turn on the face knob to raise display of the screen to show in figure 6.15. So this one you set as default lah, normal lah. So the dot is at the center. To position the center knob until 6.15, turn on the knob to display until it becomes a straight line. So first you do, here means nothing lah, is it? Nothing. Then it become a straight line. Okay, straight line means something. Select the input DC to adjust Y gain of 1 volt. So now you want to adjust it to 1 volt, and you want to see the picture 1 watt. Observe the value tracked on the screen in 6.16. Determine the voltage. Turn on the base knob, observe it. So for example, that do this, you do 1 watt, so the line like go up 1 watt. Go up 1 watt. Use your imagination lah ha. Repeat the experiment. Observe the recorded on the knob in figure 6.18. Turn off the time-based knob, observe and record. So maybe now they turn the current to front, then go to back. I'm not sure, but it's something like that lah ha. Means the electric like this ma, from here go there, now come back. So instead of going on the top, the electric will go to the bottom. For example, this one is 1 watt, but from a different direction. Select an input device to switch AC, adjust Y gain. So now, just now is DC, we want to change it to AC. So after we say AC, instead of like this straight line, when we turn it off, the line is like this straight. And what we display is, the line become like this. Just now it's like that ma. So now the line like this. Showing that this, we can think that this one is the AC current, if you want to see the electric. Okay, then this one again. Turn off the outside of the diagram. So this one there, what is the difference? Is it the same? Oh, it's different. So this one go up first, this one go down. Turn on the time. Repeat step 10 to 9, but reverse the connection in the terminal power supply. So instead of go here, go to A to B, now B to A, you want to reverse it. So after you reverse it, we'll get something like that. Same like this one lah, okay? We see the electric go on top for 1 watt, but after you reverse it, repeat step 5 in the connection terminal, observe, but reverse the connection. You can see or not? So instead of going at the top, if you reverse the battery, it will go at the bottom, producing the same watt. But just now the electric go like that, now electric go like that. But you cannot see because you are not Superman. But if you want to use OCR, then you can see, what is it? Yeah, CRO, sorry. OCR plus CRO. Then you can see the electric, whether it is direct current, how much current, is it alternating current, the alternating current go in front or go behind, and we can see the frequency of the current, see whether stable or not stable. Observation, I don't know what, maybe just write lah, the line go from the bottom up. Usually there's a numbering system at here. For example, here there is a 1 watt, here where there's 1 watt, something like that lah. So there's something for you to absorb, and you can see whether the current is, or the voltage is high or low. Okay, what is the function of CRO in this activity? Okay, so what is the function of CRO? Maybe we can say there are two functions to show the direction of the current. To show direction of current, because if the current go on top first, I know it's like that. If the current go behind, the current will go at the bottom of the graph. So it can show the direction of current, and one more thing it can show is, it can show whether it is direct current or alternating current, to show AC or DC. Okay, so now you can see whether it's AC or DC. How to see? Look at the graph lah. If the graph like that, means it is AC. If the graph is a straight line, means it is DC. Compare and contrast the different traces between the screen show in 6 and 8. Okay, compare and contrast the screen show in step 6 and 8. So let's see step 6 and step 8. Where is my step 6? So here is step 6 and here is step 8. So we can see here the electric go up and the electric go down. So what is the same thing? The same thing we can say is the magnitude. Magnitude, what do you mean by the magnitude? Here is the magnitude from the starting magnitude. For example, the magnitude is 1 watt. For example lah, So again, even though it go at this line at the bottom, but it has the same magnitude as 1 watt. So if you want to compare these two pictures, they have the same magnitude. The difference, the magnitude means this one 1 watt. Maybe up here more is 2 watt, for example. So they have the same magnitude. The difference is the position. This is positive and this is negative. Showing that the battery has been reversed. Okay, for example here from the positive to negative, and here the electric has been reversed. The direction of the current has been changed. So to use a simpler word, the magnitude for this diagram too is the same. However, the difference is one is positive, one is negative. It shows that the battery or the current has been changed. Okay, can Okay, What two inference can be made based on your observation of the trait displayed on the screen 7 and 9? What inference that you can make? Inference is something that you see and you reason. For example, if I'm sitting here taking a pen and talking, your inference is probably this guy is a teacher. Because why? Because you see him taking a pen, you see he talk, you see got a slide picture at here, the video. Probably this is a teacher. He is not a doctor. He is not a lawyer, because it looks to me that he is teaching. And the notes that's given, there's a certain reasoning for it. What to inference from? That's why inference must be based on observation from what you can see in step 7 and 9. Let me see, step 7 and 9. What can you see the difference? Okay, so this is positive, this is negative. Okay, so what inference that we can see from up here and the inference that we can see at down here? Not this one, sorry. This one. Okay, what is the difference we can see up here and down here? The inference. Okay, so the first inference we can say there is a straight line. From observation, we observe it as a straight line. So we infer that this is a direct current. Okay, it's a straight line. We infer that it is a direct current to a direction. However, for this one, it is also a straight line, but the value appears to be negative, showing that the current has been reversed or has been come opposite direction. Based on your observation, trace display on step 12 and 14, describe the change in voltage produced by the power supply. Explain your answer. So we can see from here, let's say here is 1 watt. Let's say here is 1 watt, here is 1 watt. Should I put negative? Should I put negative 1 watt? I don't. Okay, I don't think I should put negative lah. Okay, let's say I put 1 watt and 1 watt. So from what I can see, or from what I can infer also, the voltage is changing, because let's say here is 0.5, here is 0.5. So it starts from 0, 0.1, 0.2, 0.3 until 1 watt. Then it go down, back again, go up. So the voltage keep on changing. Therefore, the light spot move up and down because the voltage is changing. Sometimes more, sometimes less, sometimes more, sometimes less. Okay, so this is to answer question number 4. Explain your answer. Okay, already explained lah, because it move up and down, the voltage keep on changing. What two inference can be made on your observation for first inference and second inference? This picture, figure 13 and 14. First inference and second inference. So we can say that the voltage keep on changing up and down, showing that it is alternating current. And we can say that it starts from going to positive, then to negative. However, for figure 6.23, the voltage change positive to negative and so on, it shows that this current is an alternating current because it goes up and down. Second thing, it starts from going to negative then positive, showing that the current has been changed or have been reversed. Or one more thing we can say is the magnitude of these two currents is the same, because we can see that it won't go big, it won't go too small, but it's still the same 1 watt. So the magnitude of the current is the same. So it depends on your house lah, AC or DC. Okay. Where was I? Number 6. Name the type electric current by the following sources. Dry cell. So this one you just need to know lah ha. Dry cell is the battery. It's a direct current. And power supply. It depends. Okay, power supply either is AC or DC. It depends lah ha, on your house, and regardless of it, you always have the adapter that just now I show you, so that you can convert it. Whether your house AC DC also, but you got the thing mah, so you can convert it to AC or DC. And yeah. Okay, to wrap things up, I write here, here is DC. Why? Because it's a straight line. Straight line. So, this one is what? This one is DC. Because it's a straight line. Correct or not? I can see a straight line at here. This two is a AC, alternating current. Because the line go up and down, but I don't write go up and down lah. I will say the voltage keep on changing. The voltage keep on changing because it go up and down mah. So if you study maths, since here is V, we know that here got arrow like that, something like that. This one is V. Since the voltage keep on changing, therefore it shows alternating current. This one also is AC. I draw wrongly the graph. It's supposed to be like this. Something like that lah ha. So it's supposed to be AC because the voltage keep on changing. This one go in front, this one go behind. This one at top bottom showing the current has been reversed. This one also the same thing. One start from top to bottom, bottom to top, showing that the current is changing. So that's it for this video. I hope you enjoy it, and I see you next time. Thank you and bye bye.